Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Chinese Long March 10, a reusable rocket from China. So let's dive deep into it. So this Long March 10 or this puppy, it's a heavy lift family. Let that be clear. This is not supposed to be one rocket. They're supposed to be a family, and this family is their workhorse for the upcoming decades. Meaning, right now they have way too many small rockets. So like Long March 1, 2, 3, 4, 5, 6, 7, and no, throw all of them. One rocket series for next 10 to 20 years. So a modular core is their design, meaning this is a 3-core design and they can also launch in 1 core. So that's the core essence. Make this core structure solid, modular, sorted, and if you need heavy puppy, you launch 3 of them. When you need light puppy, you will only launch 1. And this is to take care of space ambition, because again, they cannot make Starlink competitor if they cannot launch satellite fast enough. SpaceX have, if I'm not mistaken, crossed 10,000 satellites, and they have not done it via Starship. They have done that with Falcon 9. Now imagine if you can do the same thing with your own Falcon 9, but if it was little bit better, as in it can send similar size satellites, but 5 or 6 more satellites with that per launch. Now you can hit that 10,000 satellite very quickly. So Chinese space ambition and Chinese lunar ambition, both of them require a good foundation. So this Long March 10 should be the next generation foundation, meaning they should complete it in the next 5 years, and after that for 10 to 15 years, they should not worry about it. It's like, we good, we got this. Once in a while, they might need something extra, but they good, they got this. And booster is using YF100 engine. So this engine is running on kerosene and LOX, almost like Falcon 9. However, they learned from Falcon 9, so the booster is fat. It's like, so instead of 3.5 meter, it is 5 meter. And if you know anything about cylinders, you know, if you increase the diameter even a little bit, the volume inside goes bonkersly high, meaning it has more fuel capacity. Like propellant wise, this puppy has lot of oomph. And the engines, each engine is more powerful than Merlin engine. Even though they only have 7, grand total, they still have a little bit more edge on Falcon 9 thrust performance. Now, it is a heavier rocket, duh, but with extra fuel and with extra oomph, it does have the ability to outclass Falcon 9 on a single core function. In 3-core, of course, it will be even further than Falcon Heavy. So that's the whole essence. And because they designed it from day one, powerful engine equals more fuel equals bigger fairing. That's the core benefit of having big diameter. Fairing is the very serious bottleneck of Falcon 9, because here's the deal. If you are serious about making space station, that's the biggest problem, because again, space station modules are hollow tubes. They are hollow. So they are very large, but they are not massive. So they have the ton capacity. They do not have the fairing capacity. Day one, GG fairing. So that's why 5 meter is again, it does come with some hassle, but it does give them the ability to put big engines with big breathing rooms and big fairing. And they will be upgraded. Right now they are running on kerosene engine. They will be upgraded to methyl-ox engine, which YF219. So let that be clear. Long March is a series of rocket. Core is this booster series, that's the core, and that's supposed to be modular, meaning they're supposed to manufacture the same thing and multiply it as many times as they need. And if they need to go to moon, step 2 of them. So you have to understand the philosophy of this. Every aspect is made for rapid development, meaning if, again, China may be working behind the scene for years, but the announcement to actual launch, that was quick. Like that was quick. That was not like, okay, oh, you announced it in 2010. No, it was announced after that. This was rapid. And to achieve basically complete dream of Chinese space superiority, mass production is the core essence. This is, Chinese are good at that. So the idea is fine tune this puppy. Once you're done with that, Control C, Control V with it. So they will have very high speed and they will have very low cost systems. And deadline is to land taikonauts on moon by 2030. Same thing as basically America, and that's why it's classified as a race. Both puppies are hitting the same target and they both have deadlines. Now, YF100K, it's a proven system, meaning in the previous series of rockets, they have already used this YF100K. So because it's a proven system, meaning they know how to manufacture it, they know everything ins and outs of it, and it has flown to orbit multiple times, they're good. It's a time tested system. And because they want to put humans on top of it, they're not taking a risk of trying new things, fancy things. But they have the parallel pipeline where it's like, okay, the next replacement should be ready. The replacement is YF219. This launch that happened had 219 in their upper stage, so to say. Now you're like, wait a minute. If kerosene is working, it is powerful, why go to methane? Well, here's the deal. Kerosenes were great in the older days simply because rockets were 6-minute butterflies. You launch it, 6 minutes, kaput, the end, delete. So who cares what happens to their turbo pump? Who cares the caulking, basically the black coal that it creates on everything, the soot that it creates on everything? That's very destructive. You can brute force it, you can clean it, but it's not wise. If you can avoid it, avoid it. So, and again, that's why Starship is not doing that. That's why in the early days, you can watch their interviews. They were like, we would be very lucky if we can reuse this puppy even 9 times. Because again, that coke is very difficult. Now, can you brute force it? Yes, but why? And because they are designing from blank sheet, the idea is get this to the moon. Again, at that point in time, even if it's disposable, that would be acceptable losses. But to maintain a high cadence, it has to be reusable. To maintain high reusability without bank balance destruction, go to methane. Methane does not create those complex hydrocarbon soot. Thus, your engine breathes cleanly. It's like, no more soot. So for that reason, they are already testing that. That's a parallel path. And that's why you will keep hearing the word Long March-10A, 10B, 10C. B means if there is a Long March-10B, the core is there. The first stage is kerosene, second stage is methane. If you hear C, if any future launches that you hear Long March-10C was launched, that simply means the first stage also has methane, second stage already has methane. That's why they have sub-variants into it. And yes, because kerosene is more denser, in methane series, they have to increase the length a little bit. They have to they have to make it, pull it a little bit, almost exactly like how basically this did what we say with Starship. They keep stretching it, the same thing will happen here. And again, you can see that the core reason why this is anti-scientific, so to say, again, engineers do not like it to be this thin, but they had to make it thin so they can afford to make it. Otherwise, shipping it would have become bonkersly expensive. They're like, okay, we have the money, so make it bigger. Don't make it too big where it becomes a hassle, but that's the whole point. Again, SpaceX was very poor when they designed this. Now they are not, so they can afford to make 9 meter thick. So they are like 5 meter. It's a good compromise. So what about recovery? Recovery, one thing you have to understand, this puppy is expensive. If you do that in America or Europe, you're going to go bankrupt. But in China, it's not that bad. China has a massive sea industry, massive. As in, by the time you clear the paperwork to build this in America, China would be like, okay, take it and go. Go. You don't have time for that. Like that's a fundamental difference. So I can easily see why Chinese government is like, yeah, we can afford to put this stuff there. Now, that's the bad part. It is expensive, it's big, it's bulky. That's the bad part. Good part, because their booster is bigger, basically fatter and more powerful, it is 2 times heavier. Basically, the dry mass can be 2 times higher than Falcon 9 dry mass. That means the landing structures becomes non-viable. Meaning if they made the legs strong enough, it will be same as Falcon 9. Then what was the point of having the large diameter? So they had to reduce leg weight. Why? When you are landing, you're going katonk. This puts compression. Metal does not like compression. Metal is very weak in compression. Concrete in compression is like, bro, I can do this all day. In tension, metal is like, I can do this all day. Like, to give you a context, how different rails are, like metals are, when you're talking about rails, right? I'm pretty sure most of you have studied that in school, that you have gaps between 2 rail ties, so they can expand in the summer and contract in the winter. Here's the deal. That is not true anymore. Most rails are what we call continuous welded rail. So how the heck you have continuous? How the heck it's expanding? It's not. The idea is, if you are installing it in winter, you set it on fire, the rail becomes hot, 60, 80, depending on your temperature, you heat it up, the whole rail, it expands, and then you weld it. Then put it under tension. So in summer, it loses tension, in winter, it goes under tension. And good thing about metal does not take tension under tension. It will not lose its shape, it will not buckle. So This whole philosophy is designed to harness that. It's like, hey, if you put a leg, which again, you can see that in Falcon 9 series development, the legs required a lot of engineering. It's big, it's bulky, it's hydraulic, it has crush cores, all of that. And here's the crush core does not remove energy from the system, it deforms. Where the heck that deformation energy is going? It's going into the wall, basically, that wall. Now, in case of a car, that does not matter. Here, if your rocket gets crippled where the legs are joint, yeah, that's an issue. So the idea is to act as a buffer. It has to be reinforced. The black part that you see in Falcon 9 system, they are reinforced. You can see same thing in basically Blue Origin also. That bottom part where they have legs, it's very reinforced. It's like, because again, compression. They're like, what if we don't? You remove the leg weight, you remove the structural reinforcement, and you put it under tension. Metal chills under tension. It's like, I'm chill in tension. So that's the physical reason why they are going that. And because it's a net system, they have tolerance. Basically, the landing, they can be like, I got the wiggle room is huge. And once they lock it on the top front, the other ropes are like, it stops it from swinging. So it's a very forgiving design. The whole design essence is like, we looked at Falcon 9, it's good. But if we design it to come back to land, you are paying a heavy penalty of U-turn fuel burn. What if you don't pay that penalty? Okay, great. But if you put landing legs and land it on barge, you're still paying the penalty of the landing legs. What if you throw that away also? Now you can do almost 2 tons higher than Falcon 9 with a larger diameter of basically volume and with full reusability. Meaning in full reusable mode, this puppy versus full reusable mode of Falcon 9, this can do 2 tons more with larger volume. Meaning if they are launching their satellites, they can launch, again, numbers are not clear, but apparently people are saying that they should be able to launch 5 or 10 more satellites per launch. So this is the core reason why they went through this much hassle. And again, for a bigger thing, legs would not have worked that well. You can see that in Blue Origin design. It's like, leg has to be like, they're like, no, we have to make efficient. So this is why the net recovery is there. Again, let there be any other country tries to do this, they'll go bankrupt by making this. Now, what about their moon mission, the core essence? The moon mission is basically they have to land before 2030, and that's why this design they are working on right now. And project is prioritizing trusted hardware. That's why the diameter is not bigger. They learned the hard way that if the bigger the diameter, the more messier it becomes. It's like, keep it reasonable. 3.5, cool. 5, great. 9, ooh. 12, no. By the way, that was original design of Starship, 12-meter diameter. Elon Musk actually built that carbon fiber fuel tanks and all that, 12-meter, huge one. Be mindful, there is a mathematical benefit of making larger diameter. If you have that large of a diameter, you could do 300 ton to low Earth orbit. So they're like, okay, let's be as quick, as efficient as possible. And everything is prioritizing trusted hardware. That's why they are not putting gimbals in everything. Every essence of this is designed to be as quick, as simple as possible. The whole essence is de-risk it as much as possible. And core will be reused if they need to. Right now, the most design is like use and throw, because again, they only need 2 launches. No Elon weed of 15 refueling, only 2 launches. One launches with this puppy, this is the lunar lander. Another launches with the crew, which is this crew capsule. So this is basically Orion and this is lunar lander. So they both throw, again, that's why you need rocket with that extra oomph. Both will be thrown into low lunar orbit. They're gonna make love and get married there. Then they're gonna have basically dispose of one of the kick stage, land it, do their hululu, come back to ascent stage, then transfer the crew back into the capsule, yeet it back into Earth. Now, let that be very clear. This will not be glorious as people are hoping with American systems. American systems, if they work, given the time frame, it will be glorious. This will not be glorious. This is very, what you call, methodic. It's like, we're gonna do this. We looked into Saturn V and it was stupid. While it did work, it was bankruptcy fuel. Again, NASA had to stop it. And again, they looked into N1, Soviet Union sensor. It was stupid. So they're like, thou shall not do stupid. Logical design. And again, to not waste money on developing just a flex design, they're like, okay, let's make it modular. So that's the core essence. They are optimizing it for money so they can sustain it. Having it in 2 systems, meaning they can launch this independently. If something bad happens, they're like, they're not gonna launch that. They're like, we good. And once they have that, it's like, good, we can launch crew to either lunar system or strip away the side boosters and send it into low Earth orbit. They have space station also. So that's the core essence. The whole philosophy is maximize utility, and that's the core essence. Ideally, in next few years, once this puppy is matured and sorted, that's the only thing Chinese space agency will do that. Like, we're done. Now, what can we expect in the future? This is the interesting part. You have to see, like, if you are following Chinese space basically progress, they are old, like 30 years old, and they have grown up. Like, you can easily see their philosophy change, meaning the older systems, even the current, what you have, the capsule, it literally looks like a Soviet capsule because it is a Soviet capsule, literally copy pasted from the same design. But they are now, that was our training data. Now we are making our own data. And they're taking best from US space. Like, this whole design is like, what if SpaceX had the wisdom that they have right now? How would you make Falcon 9 now? It's like, make it fatter. Instead of landing legs, use that. Again, do not start on kerosene. Day one, they already know kerosene is not a long-term sustainable system. Go to methane. Again, what was the common hurdle that SpaceX keeps getting blockaded by? Fairing size. Day one, have huge fairing size. So there is a wisdom to it. Basically, there's all saying in engineering, do it first or do it better. They are doing it better. And they learned, again, looking at Soviet Union and America, that you cannot trust government to run these things efficiently or economically. So they are also trusting the private sector without booming, without getting lost. They're not trying 10,000 things. Of course, they do have one design was like, what if we copy it Starship? But I'm pretty sure that even everybody in the China is like, try it if it works. But like, for serious thing, we're gonna trust our serious puppy. And Moon as a dream wise, like, they are very serious. Now, why America lost? Well, lost as in like, why the heck they have not already done it is because Barack Obama happened. Now, before Barack Obama smoked, there was this guy known as George Bush. Now, Bush, after the cancellation of Space Shuttle, had a project known as Constellation. It was ambitious. Like, you have to see that original designs and original proposal. It was huge. It was like, damn. Like, it would make modern SLS look like bitch place. Like, it was go to Mars. I'm not even joking. Actual plan, go to Mars. They even designed up like how will they have landing and all that. All of that. Nuclear thermal rocket was also in the papers. So they worked their ass off. And again, they built it. Orion is built from that Constellation project. It was just behind schedule. Now, when Obama came, Obama was like, we have to cancel it. It's too expensive. Fine, fine. But instead of shrinking that project, he smoked something bad. I need to find that seller who smoked him, gave him to smoke something. It's like, hey, what if we go around asteroid and we do asteroid redirect mission? I'm like, just put down the joint, man. He is the reason. For that 8 years, NASA wasted its time, money, resources, everything to chase around this stupid idea. It's like, what if you go on an asteroid? They made video of it. It is available if you want to see it. Go into asteroid, cover it in a tarp, bring it back. And you're like, wait, that sounds stupid. It is stupid. And if you're like, okay, where the heck Lunar Gateway came from? That's where it came from. When again, Trump comes on, it's like, dude, this is stupid. We need to land on Moon because China is slowly reaching that point. It's like, okay, but we have this garbage. Then they're like, then they justified it. It's like, okay, ISS has to be retired. This has no value. So what if we put ISS resources into this and now have a space station that is actually better and we have it in Moon? So that's how Lunar Gateway was. China, I'm pretty sure they would be laughing their ass off. It's like, what? What are you doing? So Chinese point of view, it's like very simple. Simple rocket, simple stuff to launch, go home, done. Sweet dreams. No 15, 20, 35 refueling missions. So they are very serious. And again, they had methodically planned it. Every aspect of it was planned periodic. And they're updating also. It's like, oh, this can be done better. Let's do it. Because again, the methane engine, that's a very recent system. The plants are very old. That's why the kerosene engine is used. But they know for a fact that if we have to continue doing this, have to have used as a better engine. And private sector, that's flying. They have 4 companies, while I last checked, that has reached orbit. If I'm lucky, in next few days, India will launch its first rocket that will be solid booster and should be first private company to put payload into orbit. They have 4. And by the way, this is liquid fueled. China is moving. They're moving ass. So the fact is that they are taking very, what you call, methodic risk. It's like, hey, we need a big rocket. We're going to make a big rocket. We need a modular rocket rather than making super giant rockets. Again, right now, they are not even touching second stage reuse because it's like, yeah, it's too messy right now. I'm pretty sure once this part is done, they will have that Starship clone that they will work on to make a better system where it's like, okay, that time they would have learned what works in Starship, what does not work in Starship, and then let's refine from there. Or maybe some other private company may come up with a unique design of second stage reuse. So future is interesting. The next few years will be tense between China and America. So this was my presentation on basically Long March 10. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst everyone. That will help me a lot. If you've enjoyed it, click the like button. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.